Hello. I don't have music going. Let's see. Uh, this one? That's what we had yesterday. All right. I have an important email coming in a bit, hopefully. And because of that, I'm unable to use my phone as the camera. So the camera is a little worse today because it's my laptop's camera. Also, well, let me just start by closing out some stuff. You go, go. Okay. And I always have so much stuff open, and I only realize once I'm going to stream. Okay. Oh, I think that's everything. Should really do this before I start my stream, huh? Nah. We don't learn. Learning would be too easy. Okay. My ad blocker wants to update. Not right now. Thank you very much. Okay, let's just quickly see what this looks like, because I'm taking up a different angle in a different space today, but I think it should be fine. Documents, project, admin of code, code dot, AOCA, screw you, screw you, you. What's this? Something irrelevant. Some notes. Okay. So we were at the point where my solution that was attempting to find all the possible ways to return movement from a sequence of buttons that need to be pressed did not return the right sequence for the correct answer from the puzzle instructions. And to be quite honest with you, I mean, I've thought about this, sure, but like, what are you gonna do? Like, I need to take a look at what's happening and then figure out why it's not working. So I don't think this is one that you can, like, you know, just think about and then solve, because it's like a logic puzzle. It's like the nuts and bolts are not where they're supposed to be. Okay. So what happens if I just run this? This sequence is not in the sequence. Which is weird, right? I think it's very weird. And again, we did test that just by not filtering them to be, oh my gosh. There it is. If true. This didn't fix it, right? Yeah. Okay. That is very strange. So this one does work. This sequence is right there. And then in order to print this one, you do left A, right A, down, left, left, A. I do left A, right A, left A. Well, that just can't be right. So I guess it's doing the sequence for left, right, A, down, left, right, A, down, right, A, down. See, none of mine are doing left, right, A, down. All they're doing is left, right, A, left. Left, right, A, down. I mean, if they did down, down, left, that would be fine. But they're not. Like, they're all doing something completely different. So, come on. What's going on here? So we got this little guy that we do find in this step. And then there's another one that we find. And then for some reason in the next step, we find all of these options, which all are based off of the second variant, it seems. So like, we can either do, you know, this or this. These two are possible. And then it seems that our code is only producing the next steps for this variant, because we always start with left A, right A, left AA. Like, they all have this prefix. So it does certainly appear. Oh, there's my email. Yes, okay, give me 1 second. I was waiting for this. Oh, I was not waiting for this. God fucking damn it. Ah. God, I hate Apple so fucking much. I hate Apple so much. Apple sucks ass. I don't like Apple. Apple sucks. I don't like them. Sold all my Apple stock ages ago. What is going on? That is so strange. Oh my gosh. Okay. Almost done here. Give me 2 minutes. I'm submitting an app to the App Store and it got rejected. For a stupid reason. A valid reason, but still stupid. Like, this is version 1.4.2 and I do not do semantic versioning. So this is literally just the 40-second version of this app. And now, for the first time in 42 updates, they finally found this bug. You know what? I'm actually gonna do one better because I think I should not change the code here at all. Okay. Let's try that one again. Product archive. It's so arbitrary how Apple review works. Like, they just have a different team now over the holidays, I'm pretty sure. And then all of a sudden, they find new stuff. This issue has been solved in build. Which build is it? 64. Okay, done. Now it needs to process. Let's make a commit out of this fix usage string. Great. And now we need to wait for build 64 to process. There we go. 64. Oh. What? Didn't I just get an email that 64 finished processing? No. I did not. Alright. Let's wait for it to finish processing. There we go. Save. After review. Submit. And then just for good measure, fill out this little form. There we go. Bing, bang, boom. Okay. That was very annoying, but necessary. And now, back to our code. So I was just saying that it seems like all of these are just based off of the first generated sequence. So this is the right answer. This is our answer. And it appears that these all start with doing left A, right A, left AA. So they all do this one. And that's not great. So I assume that somehow in our getSequence method, we override. Oh yeah, you know what? This should not be sec, this should be R. Very simple mistake. Okay. And now I have the suspicion. Nope. Okay. So, you know, they differ, right? But I assume they have the right length. So we shouldn't assert that one is in the other. We should just say that the len is equal to this len. Apparently that did not work. Well, That's probably because we need to take an element out of our sequence. Yeah, there we go. Okay, so now it's working. So all of this stuff just contains an infinite amount of debug things, so we don't really need anymore. Let's just, whoop. Man, I keep, for some reason, messing up hitting Command X. And I don't know why. Okay. So let's see if this works. I have a feeling, oh, okay, there goes my feeling. I had a feeling that my code was not efficient enough, but I guess it does work. This as the missing Historian is released. The Historian is released that a second member of their search party has also been missing. In the locked area of the ship, due to the variety of hazards, robots patched. One directional keypad that you are using, 25 directional keypads that robots are using. One numeric keypad. Okay. So we changed from 2 to 25. I have a feeling my code is not going to be efficient enough. In range 2. So this gave this number, which is hopefully the right answer there. Yes, great. Okay. And now we try cranking it to 25, and we will quickly realize that our code is not efficient enough. How do we optimize? Well, the problem is that I thought I had figured out the right rule set by prioritizing certain movements over others, but it's pretty clear that that was wrong, because I couldn't just sort the movements by the priority. Instead, we had to look at all the different options we have for sorting the different movements. So I'm going to say so we need to figure out the right permutation here, like the right order of moves. I'm gonna say that we have 4 different characters, and they all have to be sorted against each other. No, that's not right. We need to have a mapping from one key to the next. I mean, the keypad only has 5 buttons, so 5 times 5 is 25. That's how many different mappings there are. And for each of them, we need to determine the right one. So I think we can do that by just, oh, another email. We can do that by just, I mean, there are just two different ones, right? Either, like, we do at most, there's either one or two different options of movement sets to go from one button to the next. And it is my understanding that one of them will always be optimal. Like, there's no way that depending on which level we are, it becomes more or less optimal later, because one of them is always shorter than the other in the next phase, and if it's shorter, then that's better, and it will always remain better in the future. So, that being said, so it could either be, you know, let's say we have we are at the dot and we want to go to, or let's say we're at the X and we want to go to the asterisk. So then there's 4 different movement vectors that could create two possible paths. So we got up left, up right, down left, down right. And for each of them, we need to figure out the order of movements. And the order could either be vertical first or horizontal first. So we should define a seed. We should say, oh, okay, up left, vertical first, 1. Down right, vertical first, 1. Up right, horizontal first, 0. So the seed contains 4 bits. That's 16 different possible scenarios. So we should run part 1 with all 16 different seeds and then sort accordingly, freeze to the seed. Yeah. Okay. So here's what we're gonna do. First of all, I think I wanna. Okay, whatever. I think I want to submit part 1. There we go. And now let's rewrite this code. So, okay. Let's not break, let's assert false. Because we want to return early. And then instead of permutations, we do sorted no, let's call it a seeded sort of these movements with wait. Let's copy, Command D, right is this, left is this. If it's right, then I think it's down and then up. Yeah, you got it. So this is left. This is up. Wait, did I get that email or no? Still in review. Okay. And then this is indeed down. So, right, left, up, down. Right, left, up, down. Def. Okay. So we need to first figure out if it's linear movement. So that means only one of them is greater than 0. So the delta is 0 if, right? Yes, there we go. If delta is 1, we return movement. I mean, movement is a string. Yeah. No? Oh. It's not a string. It's an array. Okay. Good to know, I guess. If it's 0, we also return movement. So this means we have two different. Okay. Up left, up right, down left, down right, they're all false. If right and up right is true. If right and down right is true. If left and up left is true. If left and down left is true. Okay, great. So let's start with seed equals 1, 1, 1, 1. So the sort key is let's do up, down, left, right. And then we do the inverse sort key, which is the exact opposite. There we go. And then we return movement, but before that we do movement dot stored. Yeah, there we go. So how about we do like a bit index? And then here we just do 0, 1, 2, 3. If seed, there we go. Okay. I mean, let's just assert that this is not -1. All right. So here we invert keep. All right. So now I think we should be able to run this program again and find the right seed. And we do that by global seed for new seed in range of 16. Seed is new seed, and then we do this. Print seed and this. And this will crash. Oh? So it is not an array. It is not an array. I think we do empty string dot join results, maybe. I don't know anymore at this point. I feel like the fact that we're dealing with arrays here is sort of messing things up. Okay, I'm gonna append this, and this should hopefully. Okay, I need to take a look at my email. One sec. Okay, did get approved. Now it will probably take a second to propagate in the App Store. I think it's going to take about 5 to 30 minutes. So let's take a look at it in 5 minutes. I'm going to set myself a stopwatch. Okay. All right. For some reason, my stream preview shows me as offline. Okay, problem resolved. Nope, that didn't right. Oh my gosh. What am I doing? I don't think I'm in top shape today. Anyway, so why is this happening? Because it's not append, but extend. I think. Aha. There we go. So now we just do a try. And then exception, pass. Okay. 2 different seeds worked. 3 and 7. I don't know if either of them produced the right output. No, they did not. Great. So apparently we can't just sort by the vector, but we have to sort by ooh. We need to sort by source button and destination button, maybe? Maybe even that wouldn't work. One 89174 is not correct. Nope, it's not. Well, that sucks. Real bad. Real bad. So maybe we need to take a look at I mean, source button and destination button gives us 25 permutations, except that's wrong because it's actually I wonder if we maybe messed this one up. Maybe this one has a different seed. We could double the seed and bit shift if we're taking a look at the other keypad. Maybe that's right? Let's see. I don't think that's right. 1, 2, 3, 4. So now it's not 16, but it's instead 128 maybe? Is that right? What is 2 to the power of 8? 256. Cool. Let's see. We attach the keypad. My timer is up, but I don't think the app is released yet. I'm trying to make a TikTok video. Once it's done, that's why. Let's see. Oh, all right. It has indeed finished processing, and I'm gonna post my TikTok video now. Gotta choose a good cover. Which is difficult when you look like me. And all the cover options include your face. Okay. And post. Okay. Good stuff. So what was I saying? Seed. If keypad equals A, then seed. Four. I think that's right. Yeah. Okay. I really don't think this is it. It might be it. But I really don't think it's it. So we're looking for 184. 184, 7, 118. 184, 7, 118. Nope. Not in here. I mean, let's double check, but pretty sure it's not in here. Nope. Okay, so we can't just sort by the vector. Well, how many different ways are there? Like, how many different combinations of keys do we have to optimize? On this keyboard, and I would actually say that we could return options. R for our end results. I mean, that's just the same thing, hopefully. Yeah, you got it. Okay. So this code currently just returns one option. But if we look at keypad A, we might as well just return all the options, because at that point we're like in the last step. So if we continuously just have a single option up until the very end, then we're golden. So I would say let's perhaps, just in 1 second, I'm gonna go roll back the movement method to the one we used for our submission of part 1. And I think in doing so, we can split this method into 2 different variants. One that's seated sort, and one that's for keypad A. In fact, now that I think about it, let's just do that literally right now. Because there's a tiny chance that oh, that's the wrong repository. No, it's not. What? Is it just this? Yeah, okay. Let's see. So this one returns all movements. So let's call it all movement. All movement. There we go. And then which one is keypad A? A is the big one. Okay. All movement. If Keypad is A, return all movement. There we go. Oh my goodness. All of these seats all of a sudden work. So it turns out we need to optimize keypad A, but not the other ones. Great. Well, let's lock in the seed. Which is going to be 1. And then I do kind of like this method, so let's just like let's just do this. Let's maybe just perhaps run it with 25. Come on, is the string getting too long? What? Nothing's getting printed? How's that possible? Oh, I see. Okay. So we only have one option anymore, but the strings are just getting so long. So I was optimizing the wrong thing the whole time. Well, that's a little unfortunate. Because I have a feeling that we're probably not exploding in the number of options at all. Oh, we are. Okay. So we did have to optimize that part. That was part of it. Okay. All right. Well, I'm not mad. So that means we're getting much, much further now. But, you know, probably the length of the string is like in the millions now. I mean, are we already at 25? No, we're not even close. So let's just print the len of sequence 0, and then we probably find out pretty quickly that this is a horrendously large number. Did I remove the music from my TikTok? It did not. Okay. We are good. So. That means... Well, I want to test something first of all. Are we still getting the right answer for part 1? We are, indeed. Okay. So now we need to start optimizing repeated button presses. That's my theory. I think this is really about repeated button presses. I might be wrong. I might very much be wrong. What? Oh. So it's like 900,000 characters long. That's pretty long. I'll give it to you. That is pretty long. So here is the thing. The thing is, I have no idea. It's not about repeated button presses, turns out. There are probably similar subsequences that will turn into the uh, exact same output. So this is like a zip encoding, right? Like a, what do you call it? Like a Huffman tree, where you're trying to find the most common, like the longest, most common subsequences. So I would love to find like the shortest amount of, if you multiply the amount of sequence times. Oh, I don't know what I'm talking about. So we want to find sequences that start and end in A. I think that's a given. Um, and then we can compress those, and if they start and end in A, we can just all string them together. The next step, that is. Because the whole thing starts and ends in A. Ain't that right? I think that's right. No, it does not. So it starts and ends in A, but the first A is silent. So the suffix is always an A, and we assume that the last character was an A. Okay, that makes sense. That makes sense. So how will we find common subsequences here? I don't know, man. In fact, I have no idea. One thing we could do is literally just take this thing, put it into a new editor window, and then start randomly selecting characters. Wow, there's a lot of shared subsequences here. Like a lot. It appears like, this is sort of the sweet spot. But how does one do that? Like, how do we find these shared subsequences? I think it's literally just Huffman coding, but I don't know how Huffman coding works. Okay, let's ask ChatGPT. How does Huffman coding work? If I want to write an algorithm that finds longest common subsequences, like in zip compression, how would I go about that? You wanted to find the longest sequence that appears in both A and B. No, that's not quite right here. We have one string, and we want to find subsequences that are both common and long. Suffix array construction. What? The longest repeating substring. I mean, can we just like just go through like 4 characters at a time and it just keeps fucking repeating fucking everywhere? Because all this stuff is like super common. There are only 4 different values. Like, what if we just go for like 8 characters at it? 4, 1, 2, 3, 4. Yeah, seems perfectly reasonable. How many ways are there to arrange up, down, left, right, A? 5 different characters in man. Ugh. I feel like I'm just too tired. Like, I just can't think anymore. It is 10 p.m. I have gotten a lot done today. And we also did get the first part. And it's a Sunday. And I was up until like 1 a.m. working this. So, you know, maybe it's just a sleep on it angle. Maybe it's just a sleep on it angle. The TikTok is doing all right. Not amazing, to be fair. But it also just got 100 views so far. So we're just getting started. I can't quite figure out how to like, honestly, the order just doesn't matter, right? Like, if you just take all the sequences from one A to the next, or rather, like, we split the string by A, we take every single unique combination. I think that might be right, you know? Like, we have a way to optimally How about we just run the code as is until we only have one option, and then we start running an optimized version of it that takes a look at every single substring as split by a's, and then if it's a unique one. Yeah, I think that's the answer. Like, we don't have to find long subsequences. We can use short ones, because the short ones, there's only so many of them. So we only have to, like, what, do 25 at most? 25 different conversions, and then we're done with the whole thing. I think that might be the right answer. Sec of sec. Sec. And then else this. And then here we assert false. What? Oh, we're still running. Yeah. Let's just call this run iteration is 2, and then we just run 25, and then easy we run 2. There we go. Okay, now we should have a insertion error because we're gonna start writing this. Okay. So I'm gonna say if sec is list, sec equals, no, if sec 0 is string, right? Then sec is sec 0, 1. I think that's right. And then for lookup equals this, result equals this. For s and in, if s in lookup, then result of s result of get else n. There we go. Lookup is sec of s underscore. For s in s split a s plus. There we go. Okay. result.get lookup plus n equals not sec. I think it's called get sec b. And I think this is s. Yeah, sure. Get 0 from it. I don't care. There we go. That's not a lookup. Then we do this. Okay. And then I think we yeah. And then we return KV for KVN items. Maybe? I don't know, man. Not enough values to unpack. Expected 2, got 1. I see. What the hell? Is this not this? I think we gotta check instance off. Is instance. Sure. Yeah, better. Okay. Something happened. I don't know if I trust the single digits, the single characters. I mean, maybe, right? Like, let's say we have an A press. An A press should return an A press. Well, French. Nah. If is instance string, then we do this. Otherwise, so this is going to be the L value. For KV in sequence 0, L plus equals this times len of key, perhaps? I mean, this is going to be a truly humongous value. It might just be right. I don't know. So they don't give us a test value. That's great. That's great. That's stupid. Like, how am I supposed to know if my code is right or not if it's not giving me an example? Well. So here's the problem. The problem is, well, maybe there is no problem. There is a problem. Like, my thinking was, the last A at the very end is getting duplicated, right? Okay, well, maybe it wasn't quite as easy as I thought it was gonna be. However, I think I still need to take a break. My brain is fried. I just can't come up with a better solution right now. Like, it feels like the order of these sequences does not matter at all. Like, if we do ABA and then ACA, or ACA and then ABA, you know, not that B or C are valid characters in this example, but that doesn't really make a difference. So I think we have the right approach, that we take a look at subsequences and then we run the logic on the subsequence, and then we remember how many of those we had, and then we add the numbers together later. I just think that we have an edge case somewhere, an off by one error, if you will. And I have no idea what it is. I think it's right to take... Well, you know what? We could just test it with, like, small values of, like, you know, 10 characters or something. But not now. I need to take a break. I'm gonna do that tomorrow, probably. I haven't even looked at today's puzzle, but we'll do that in time, for sure. All right. I'm gonna take a break, and I'll be back soon. Bye-bye.